Now let's see a pipeline, and then we'll see how this operand forwarding is going to be useful. The technique that we are going to discuss is operand forwarding. And there are various names for this. Some people say that it is also called as short circuiting. Some people say it is operand forwarding, right? Or sometimes they will even describe it orally, completely in words, saying that this is one phase. From one phase, the operands are sent to the other phase directly without even mentioning this name. So whatever it is, the main advantage of using this particular technique is if one stage needs some values which are being computed by the other stage, and if the other stage is going to take some time to provide the values, then we can get it directly through operand forwarding. So I'll take an example pipeline, then you'll understand it. Assume that we have this particular pipeline in which we are having 5 stages. The first stage is instruction fetch and instruction decode. So fetching and decoding are going to happen in this phase. And then the second phase is operand fetch. So in this operand fetch, we are going to fetch the operand from the register file, and these will be provided as input to the ALU, where the execution of the instruction will take place. Now whenever the instruction is being executed, the result of it, the whatever that final result we get after execution, that will be stored into a temporary register. And after this execution, if there are any memory reference instructions, they will be executed in this phase, right? Let us say it is memory reference. So memory reference means either reading from memory or writing to the memory, that will be executed here. And finally, write back. So write back is the phase where whatever is computed either during this execution phase or whatever is being read during this memory read phase, so they all will be written back into the register file during this phase. So if you want to understand what is going to happen here, you can think of it like this. So one thing is, we are going to have register files, and in the register file we are going to have all the registers like R1, R2, R3, so on, okay, so on. All these registers will be available. And then we have one ALU, arithmetic logic unit, and to this ALU there will be 2 inputs and 1 output, right? And then there will be one memory unit, and either to read into this memory unit or write into this memory unit, we will be using one temporary register. These two are temporary registers. This one is temporary register and this is temporary register. Generally this register is also called as memory address register, or sorry, memory buffer register, okay, MBR, memory buffer register. Whatever is has to be read from the memory will be read into this, or whatever has to be written into the memory will be written from this, okay. So now if you observe this instruction fetching and decoding, here you are going to fetch the instruction from the instruction part of the memory. And operand fetch, in this phase, what this phase will do is it will select the operands and it will read into these input registers, okay. And in the execution phase, the exact operation is going to be performed here and the result will be written into this temporary phase. And in this memory read, whatever you want to read from the memory or whatever you have to write it, it will be written. Let us assume that we are trying to read it. So then something will be read into this temporary register. And write back is the phase where whatever is executed during this execution, either during this execution something will be written in this temporary register, or during this reading something will be read from the read into the temporary register. In this case, they will be stored back into these registers, right? Therefore, anything that is evaluated during execution phase will not be written back into the registers until the end of this end of the write back phase. Got it? So such a pipeline might create a problem in executing these instructions. Let us say one instruction I1 is like this. R1 is being computed as R2 plus R3, right? And the next instruction is like R4 needs R1 plus R5. Now whatever is being computed during execution phase of first instruction is needed during the operand fetch of the second instruction. Now let's see what is the problem with this. Now if you observe this, see what happens in this case of this pipeline is, first this instruction will be fetched and it will be decoded, and it will be understood that we have to add two resistors R2 and R3 and store back the result in R1, right? Appropriately control signals will be generated. Now in the operand fetch, what will be fetched is R2 and R3 will be fetched. R2 and R3 will be fetched, right? So where will they be fetched? They will be fetched from these two resistors into these two, got it? And in the execution phase they will be executed and R1 will be available in the temporary register, which means whatever the result of this will be available in the temporary register, which means as the output of the execution phase, the result will be present in the temporary register. Let us say this is temporary register 1, temporary register 2, temporary register 3. So the result will be available in the temporary register 3, right? And in this memory read, there is no memory read or memory write, therefore memory reference is not required for this instruction, but still it will be included there, which means one pipeline will not be doing anything for this particular instruction. And during this write back, this is the phase in which T3 will be written back to the register file, which means finally R1 will be available here. Got it? Now if you try to execute the next instruction, which is this one, you will start with instruction fetch and decode, instruction fetch and instruction decode, and now the next one is operand fetch, and the operands that have to be fetched are R1 and R5. The operands that have to be fetched are R1 and R5, but if you observe this one, R1 is not available until the execution of this phase, right? So that is the reason you cannot perform this operand fetch here. You cannot perform operand fetch here, and you are supposed to introduce these stall cycles. So you are supposed to halt, and here only you can start with operand fetch, right? Therefore 3 cycles are going to be wasted. In order to save from this particular problem, we are going to use something called as short circuiting or operand forwarding. So what is operand forwarding is, if you observe this particular pipeline, we have instruction fetch and then instruction decode. After this we are going to have operand fetch, and after this we are going to have execute, and after this we are going to have memory reference, and finally we are going to have write back here, right? Now this technique operand forwarding says that actually whatever has been computed here or whatever has been read here will be written back into the registers only after this. But then this particular technique says that whatever has been computed here should be provided as the input to the execution phase without waiting till here. So if you want to understand it clearly, you know that to the execution phase we are going to provide 2 temporary registers into which the operands will be read during the operand fetch phase. Where will they be read from? They will be read from the register file, isn't it? Now the output of this is going to be stored in a temporary register. This particular this one says that without waiting for the write back stage to copy this this register into the register file, you can directly write it back here. Got it? So what does it mean? So whenever this execution file, this one is over, right? So this one is going to take as input TR1 and TR2, right? So this TR3 can directly be written into TR1 like this. From here itself it can be written here. Therefore whatever is required by the next instruction, which is R1 is actually available here, which is present in T3, isn't it? Which is present in TR3. Now that particular value can be written into the TR1, and so the next operand fetch can happen here. Even though it is going to read wrong values, it will be replaced by the right value after the execution phase of this one. So you can start execution here, right? This execution requires that R1 and R5 be present in the input registers. Yes, R5 is already loaded during the operand fetch phase into one of the temporary registers, and R1 is provided through the short circuiting, right, like this. Got it? And so after this execution phase we can start the next execution without delaying, right? And even if operand fetch is going to fetch wrong operands, it doesn't matter, because they will be replaced by the correct operand by this operand forwarding. So the output of execution is going to execute phase is going to be provided as the input to the execute phase, and after this you can continue as possible. And here also, from here, generally if you are reading something from the memory, you have to wait for the write back phase to write it into the register file, then only the next instruction can read from the register file. But without waiting for that phase, you can apply this one. Got it? So if you try to do this, this is called as short circuiting. So you can start this in simple words you can understand like this: whenever execution of an instruction is over, the execution of the next instruction can start without waiting for the write back phase, because the output of the execution phase is provided to as the input to the execution phase. Therefore, for the next instruction, whatever it needs will be present at its input, right? So this technique is called as operand forwarding. So using this technique, we'll be able to avoid some of the stall cycles, right? So we'll not be able to avoid all the stall cycles, but at least we'll not delay or will not waste as much time as we were wasting earlier. We'll waste only a few cycles. In most of the cases, this will help us in completely avoiding the stalls. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.